Hello everyone, welcome to Math 1350. More on math. Today's exciting topic, we will be discussing Chapter 6, Section 3. Section 3 deals with multiplication, division, and estimation with rational numbers. So we're going to talk about multiplying, dividing, and estimating fractions. First off, remember, what does 3 times 2 mean? Not what it is. We all know it's 6. But what does it mean? What does multiplication really mean? What multiplication really means is 3 times 2. 3 2's. So we add 3 2's. 2 plus 2 is 4, plus 2 is 6. So that's what multiplication means. The reason I'm saying that is because what if we had 3 times 3/4? Not 3 and 3/4, 3 times 3/4. What this means is 3/4 plus 3/4 plus 3/4. They all have a common denominator. Just write that once. Now we just worry about the top. 3 plus 3 plus 3. 3 plus 3 is 6, plus 3 is 9 over 4. How many times does 4 go into 9? Twice. 2 times 4 is 8, so there's 1 left over. Remember, this is always the bottom number. So that's improper mixed number. That's either one. In word problems, anytime you see the word of, that means multiplication. Yeah, so very important. Anytime you see the word of, for example, the word problem. The world is, or let's see, 3/5 of the world is covered by woods or woodlands, and only 1/2 of that is rainforest. How much of that? So how much of the world is rainforest? So we took, since we know 3/5 of the world is woods, and of that, 1/2 is rainforest. So 1/2 of the woods is rainforest. Whenever you multiply, top by first off, here's a rule that a lot of places don't tell you about. Before you ever multiply, always reduce first. Make the numbers smaller when you can. If nothing cancels, then top by top, bottom by bottom. 3 times 1, 5 times 2, so it's 3 over 10. And later on, if we want to talk about percentages, that means 30% of the world is rainforest. Now, when you teach kids this stuff, how are you going to do it? Well, let's look at 4/7 times 2 over 3. Well, yeah, we could teach them 4 times 2 is 8, 7 times 3 is 21. What does that mean to them? 8 over 21, 2 over 3. Well, Now, what we have to do here is a method called shading. Let's look at both of these. This is the first one. This is the same as a matrix. I don't know if you hear a matrix, rows and columns. So if I say 3 by 4 matrix, there are 3 rows and 4 columns. Or 5 by 6, 5 rows, 6 columns. The same thing when it comes to multiplying fractions. So we have a box. Yeah, we always refer to boxes. Since we're dealing with rows, let's create one, two, three, 4, 5, 6, 7. We have 7 rows. We want 4 of them, so we're going to shade in 4 of them. Now we'll multiply. Now we need, remember the bottom number is how we had 7 here. Now we need 3 columns. We shade in 2. We only want to care about where they're overlapping. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There we have it. That's how graphically how we can represent this stuff. So we're only looking at where they overlap. Alright. Which leads us to our theorem. Theorem 6-10. The multiplicative identity property of rational numbers. The multiplicative identity. So we have a fraction, a over b, and you multiply it by 1, then you get a over b. This is the important part. Remember, a over b times 1. 1 is anything over itself. It looks different, but it's the same ratio. That's the first one. Then we have the multiplicative property, or inverse. This identity, we need the inverse property of rational numbers. Remember, the inverse property helps us. Well, we had a plus what makes it, gets rid of it. Negative a. A times what equals 1. So when you add, subtract, it equals 0. When you multiply, it equals 1. Well, we have the fraction. This is how we first discussed it. But now we deal with fractions. If I had a fraction, a over b, what times a over b is equal to 1? The inverse of a over b is b over a. Just flip it. Works here too. A is a over 1 times flip it 1 over a, you get 1 because they cancel. A cancels, b cancels, left with 1. So that's our first set of rules. Theorem 11. These are the properties of rational number operations. The distributive property. If we have A times B, A over B times C over D, plus or minus, doesn't matter which one we're using, E over F. Again, the distributive property earlier, we use this. Coefficient is A, so we multiply it to everything inside there. Same thing here. The coefficient is A over B, so A over B times C over D. Whatever that operation is, A over B times E over F. And either reduce first, or if nothing reduces, then multiply straight across. And then add or subtract them. Number 2. The multiplicative property of inequality. A over B, fraction A over B is equal to fraction C over D. That's it. If A over B, then what has to be true? Then there has to be another fraction that we can factor out. In the past, we used to talk about if A equals B, then A times N equals B times N. Same thing there. The multiplicative property of inequality. If A over B is greater than C over D, then A over B times some fraction E over F is also larger than C over D times that same fraction EF. It also works if it's less than. If A over B is less than C over D, then that's going to be less than. So I could put them both there. All right. Multiplicative property of 0. A over B times 0 is 0. Yeah, duh. Yeah. Anything times 0 has always been 0. So let's see how we use this stuff. Here's an example. An item was on discount for 3/4 off the original price. The sales price was $330. What was the original price? And I was on discount for 3/4 off the original price. So that says, remember, it's off of the original price. So it's 3/4 of, that's multiplication, the original price. We don't know what that is. We don't know what that is. But we do know 3/4 of the original price became $330. That's what it sold for. So whatever the price was, we took 3/4 of it, and it equaled $330. Find X. What was the original price? Remember the inverse property. It's up there. I'll have to show it to you. How do we get rid of 3/4? Well, because 4 is on the bottom, we have to multiply by it. And since 3 is on top, we have to divide by it. So we multiply by the reciprocal. Both sides. To get rid of the 3/4, we multiply by 4/3. Because the 4's cancel, the 3's cancel. So we're left with the original price. Remember, get used to not multiplying fractions straight off. Reduce first. How many times does 3 go into 330? 3 goes into 3 once. 3 goes into 3 once. 0. So 3 goes in there 110 times. 110 times 4. So the original price was $440. So make sure you have to understand what the question's asking, the way it's asking. We have to set it up first. Multiplying mixed numbers. Two and 1/2 times 2 and 1/2. First off, we have to expand this first one, which is 2 plus 1/2. Then the second one, 2 plus 1/2. The same thing. We have 2 terms inside parentheses, so we FOIL. 2 times 2 is 4. Then positive is positive is positive. 2 times 1/2. Positive times positive is positive. 2 times 1/2. Positive times positive. 1/2 times 1/2. We have to FOIL it. So let's see what we have here. Combine like terms. 2 times 1/2, the 2's cancel, so it's just 1. 2's cancel, so it's just 1. 1 times 1 is 1. 2 times 2 is 4. 4, 5, 6 equals 6 and 1/4. Pretty cool. Division of rational numbers. by the 6th grade. Students should be able to take any fractions, A, B, C, D, and E, F. These are all irrational numbers, where C, D does not equal 0. And they should be able to A times B divided by C times D equals E times F. If and only if EF is a unique rational number such that CD times EF equals AB. We'll get to that, what that means in a little bit. I mean, that's just a bunch of ways of saying the same thing as this. If 8 divided by 4 is 2, then 2 times 4 equals 8. Or at least 4 times 2. If 8 divided by 4, 8 divided by 4 is 2. Then 4 times 2 is equal to 8. Same thing works in fractions. Alright. Then we have Theorem 6-12. This is where it starts coming together. Any fraction AB divided by any rational number CD is equal to AB times the reciprocal of that. So it equals A times D over B times C. Whenever you have fraction over fraction, I'll show you how it works, but always take the first number, leave it alone, change the signs, and flip. The next one is A times B divided by C times D is equal to A plus C, B plus D. These are pretty interesting rules, but they work. So yeah, so keep those in mind. We'll use those a little later. Let's look at some examples of what fractions we can look like in multiplications. "12 times 25 to 1/4. Okay, this is not distributivity. Remember, distributivity, you have to have a plus or a minus. So you can't distribute that. These are all multiplied. Since they're all multiplied, what this means because of the commutative property, x times y is the same thing as y times x. I can move them around as long as they're still multiplied. So I move this next to that. I'm going to do those first. So it's 12 over 1. Remember, before you multiply, always reduce. 4 goes into 12 3 times, and once again, so we have 3 times 25 equals 75. That's one example. 5 1/6 times 12. Remember, since this is a mixed number, It's 5 plus 1/6 times 12. Since there's a plus there, I can distribute now. 5 times 12 plus 12 times 1/6. 5 times 12 is 60. 6 goes into 12 twice, so this equals 62. Four fifths times 20. It's all multiplied, so before I do anything, I cancel. This 5 goes into 20 4 times, so 4 times 4 is 16. So you have to be very careful. There's a multiplication sign there, and it's multiplied there. This becomes a plus, so now you can distribute. This is just straight up. Estimations. Get 3 1/7 times 7 8/9. So this one becomes 3 plus 1/7. 7 plus 8/9. Remember, we're estimating. So this is pretty close to 0. This one's pretty close to 1. 3 plus 0 is 3. 7 plus 1 is 8. 8 times 3 is 24. There's my estimation. This is my estimation. Okay, so some bigger, uglier ones. (24 5/7) divided by 4 1/8. 24 plus 5/7. 4 plus 1/8. All right, remember we're estimating. So this one here, okay, we're estimating. If you want to, you could just say 1/2 even, go down. And then 1/8, that's pretty close to 0. So we have 24 plus 1/2 divided by 4. What this means is that this 4 goes under both of those sets. (24) divided by 4 is 6. Now, whenever you have a fraction over a fraction, take the top fraction, leave it alone. Multiply by the flip of the bottom. So this is over 1. So we have 1/2 times 1/4. 1, so it becomes 1 times 1 is 1, 2 times 4 is 8. So the answer is 6 1/8. Or what if you went the other way with this? because it's estimation. We had 24 plus 5/7 divided by 4 plus 1/8. What if we just went ahead and made both of those go to 0? So we have 24 divided by 4. There's another one you could have done. 24 plus 5/7 divided by 4 plus 1/8. Round that one up. 24 plus 1. Round this one up. 4 plus 1. 25 divided by 5 is 5. So, I mean, the accuracy, it's whatever the most logical one. Well, the closest one I would go with is 6 1/8. But this one goes way too far. I mean, you're changing numbers pretty large. All right. Now let's talk about exponents. Yay. Rules of exponents. We know what they are. Exponents are those. A times A times A times A. N times. That's the exponent. This number down here is called the base. So the exponent tells us how many times we multiply the base to itself. Two to the fourth power is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, let's look at the rules of exponents. First one. The same bases, different exponents. Or it could be the same. But whenever you're multiplying these numbers, you add the exponents. So, for example, if we had 3 to the 5th times 3 to the 2nd, it'd be 3 to the 7th, which is 5 plus 2. The question is why? 3 to the 5th is 3 times 3 times 3 times 3 times 3, 5 times. Times 3 squared is 3 times 3. 1, 2, 3, 4, 5, 6, 7. So we have the same number, the base, multiplied to itself 7 times. So it's just a lot faster if we just add the exponents. A power to a power. Whenever you have a power raised to another power, you multiply the exponents. So 3 squared to the 5th is 3 2 times 5, which is 3 to the 10th. Let's see what this means. So this is inside parentheses. It's raised to the power 5. So we have 3 squared times 3 squared times 3 squared times 3 squared, 5 times 3 squared. We have 5 of these. Now what does this mean? 3 times 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 3, 3 times 3. The same number occurs 10 times. So it's a lot easier if we do it that way. We have a product of numbers inside parentheses raised to a power. This property tells us distribute to anything inside there. So if we had 3x to the third, it would become 3 to the third, x to the third. 3 times 3 is 9, times 3 is 27, x to the third. 3x times 3x. Yeah, this number says I multiply the base 3 times. So it means 3 times x times 3 times x times 3 times x. The associative and the commutative property says I can move these numbers around. I could group them numbers to numbers and letters to letters. There are 3 of those and 3 of those. And then 27x third. This also works with division. If you have a fraction raised to a power, same logic. It's just all you do is expand it. You have n of the top ones, n of the bottom ones, so it becomes there. Now we have fractions. Whenever you have fractions, take the top exponent minus the bottom. That's, in this case, that's if m is larger than m. In other words, 3 to the power 5 over 3 to the third. 5 minus 3 equals 3 squared. 3 times 3 times 3 times 3. That's what the top number equals. Divided by 3 times 3 times 3. That's the bottom. They cancel. All we have left is 3 squared. Same part. If n is bigger than m. So in other words, when we have fractions, always go to where the bigger exponent is. And since you move this one, there has to be something left in its place. So 3 to the power 3 over 3 to the fifth, 1, 5 minus 3. 1 over 3 squared. 3 times 3 times 3 3 times 3 times 3 times 3 times 3. Bang, bang, bang. There's a 1 there. So whenever you have fractions top and bottom, just move the smaller to the larger. That's pretty much all there is to it. But number 7 is an interesting one. X to the m over x to the n. If n is bigger than bottom. This looks at the last question. Normally, if n is bigger than m, you do it on the bottom. But what if you didn't? What if you put it on top? Look at what happens here. This defines a new equation. So 3 to the third over 3 to the fifth. Third minus fifth. 5 is bigger than 3. The answer is negative. Now we're looking at negative exponents. Negative exponents do not make the answer negative. All a negative exponent means is change the location. Change the location of the number. If it's on top, move it to the bottom. If it's on the bottom, move it on top. So let's look at this example here. I mean, we know that since 5 is on the bottom, we'd have 2 left over. So 3 to the power negative 2 is the same thing as 1 over 3 squared. Which is what this says. Alright. We know what x squared means. Remember, it's x times x. Why is it x times x? Because from rule number 1, if you have the same bases, what do you do with the exponents? You add them. But how can this be? These don't have anything up there. X to the first power is just x. So x to the first times x to the first is x squared. Because of that. If there's nothing there, it's automatically a 1. Which then brings us to our last. Anything to the 0 power. Wrong. It's 1. Why? Let's see. This is a formal proof. What equals 1 in mathematics? Anything over itself. 3 over 3, 5 over 5, x over x. So it could be anything. I can make it exponentials. Rule 5 says whenever you have fractions to the exponents, same bases, we just subtract the exponents. Since they're both the same, n minus n is 0. And there's the reason why. So now we're ready to do the homework. Alright, good luck everybody.